Welcome back to JEasin. Today we learn how functions behave when we combine them, like adding, multiplying, or composing functions. This is the foundation for calculus, transformations, and advanced G problems. When we have two functions, say f and g, we can create new functions by combining them. Just like numbers can be added and multiplied, functions can be too. Given f and g is equal to f plus g is equal to fg is equal to f times g and is equal to fg, where g is not equal to 0. These are new functions. Whenever you combine functions, the domain is the intersection of their individual domains. And for division, we also must ensure that g is not equal to 0. For example, if f is equal to x with domain x greater than or equal to 0, and g is equal to 1 with domain x is not equal to 3, then the domain of is 0, excluding 3. Always check the domain first. Let's look at examples of basic operations. For addition, if f is equal to x superscript 2 and g is equal to 2x plus 1, then is equal to x superscript 2 plus 2x plus 1, which simplifies to superscript 2. For multiplication, if f is equal to x superscript 2 and g is equal to sin x, then is equal to x superscript 2 sin x. For division, if f is equal to ex and g is equal to x superscript 2 4, then is equal to ex. The domain for this function excludes x is equal to plus or minus 2. Now, this is the most important part, composition of functions. Given f and g, the composition is defined as f, meaning you first apply g, then you apply f. Think of it as putting one machine inside another. Let's look at simple examples of composition. If f is equal to x superscript 2 and g is equal to 3x1, then f becomes superscript 2, which expands to 9x superscript 2 6x plus 1. Now, for g with the same f and g, we get 3 1, which is 3x superscript 2 1. It's important to note that f is generally not equal to g. The domain of composite functions is super important for g. To find the domain of f, first find the domain of g. Second, the values of g must lie inside the domain of f. And third, apply any extra restrictions. Consider a g-style example. F is equal to x and g is equal to x superscript 9. We need to find the domain of f. The condition is that x superscript 9 must be greater than or equal to 0, which means x is less than or equal to 3 or x is greater than or equal to 3. So, the domain is the union of composition with log, root, and trigonometric functions appear regularly in G. For example, if f is equal to log x and g is equal to, then f is equal to log. The restrictions are that 3x must be greater than or equal to 0, meaning x is less than or equal to 3. Also, must be greater than 0, which means 3x must be greater than 0. So x is less than 3. Therefore, the domain is, let's consider composition with modulus. If f is equal to x superscript 2 and g is equal to vertical bar x2 vertical bar, then f is equal to superscript 2, which simplifies to superscript 2. The range remains the same as f is equal to x superscript 2. Now for some G previous year question level examples. PYQ example 1. If f is equal to x plus 1 and g is equal to 2x, find f. Step by step, f is equal to 2, then g is equal to 4, and finally f is equal to 5. The answer is 5. PYQ example 2. If f is equal to sin and g is equal to x plus 1, find f. The composition f is sin. Here's an advanced example. F is equal to and g is equal to 2x1. Find the domain of f. The condition is 1 superscript 2 must be greater than or equal to 0, which means superscript 2 is less than or equal to 1. Solving this, we get 1 is less than or equal to 2x1, which is less than or equal to 1. This simplifies to 0 is less than or equal to x, which is less than or equal to 1. So, the domain is the closed interval 0, 1. In summary, functions can be added, subtracted, multiplied, and divided. The domain is always the intersection of the individual domains. Composite functions are the most important, defined as is equal to f. The domain of a composite function involves input restrictions plus inside function restrictions. Composition appears everywhere in G: limits, continuity, and derivatives. In the next episode, we go deeper into the most powerful part of functions: composite functions with G tricks, including how to simplify them quickly in the exam. Keep learning with Jay Eason. Your mastery is building step by step.